Well, good afternoon. Thank you to everyone who's joining us for the first time, and those of you that have tuned in before, thank you again for joining us today. I'd like to thank you all for tuning in to this great virtual field day featuring our Conservation Learning Labs project. We're excited to share with you a little bit more about the project and some of the ongoing water quality monitoring results. So a little bit about the Iowa Learning Farms for those of you that may not be familiar. We were established in 2004, and our goal is to build a culture of conservation by working with farmers, landowners, researchers, and conservation professionals to implement practices that both improve water quality and soil health while helping those producers remain profitable. So our partners in doing so include the Iowa Department of Agriculture and Land Stewardship, USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, Leopold Center for Sustainable Agriculture, the Iowa Department of Natural Resources, US EPA Section 319, Conservation Districts of Iowa, Iowa Farm Bureau, Practical Farmers of Iowa, GrowMark, Iowa Agriculture Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center. So just a brief bit of housekeeping. For those of you that haven't tuned in before, we do ask that you keep your cameras off and yourself muted while the video is playing. Following the discussion, you are invited to unmute to ask your questions of Matt and Mark, but you can also submit those at any time via the chat box. Following today's virtual field day, you'll be receiving an email from the Iowa Learning Farms asking you to provide a little bit of feedback on the virtual event. You'll have the opportunity to also then let us know if you want to receive a free Iowa Learning Farms NetGator by providing your mailing address. And you'll also get a link to the recording of today's virtual field day. So if you know someone that was wanting to attend but couldn't make it, please do share that link with them. And then you can always go back and take a look as well. So today we have two great speakers for you. We've worked with them many times and we're pleased to have them on today. Mark Licht is an Iowa State University assistant professor and extension cropping systems specialist. And Matt Helmers is the director of the Iowa Nutrient Research Center. So let's take a look and learn a little bit more about the Conservation Learning Labs project.
Hello, today we're out at the Conservation Learning Labs in Story County, and we're near the crepe wetland of this CLL project. We also have Matt Helmers with us, and Matt, why don't you start off with just describing the project a little bit?
Yeah, the Conservation Learning Labs project it's a unique project, and so it's a project where we have two watersheds in Story County and two in Floyd County, really leveraging water quality monitoring that's being done by Dr. Bill Crumpton. So at each of those four sites, again, two in Story County, two in Floyd County, there's a wetland at the exit of each of those small watersheds. Primarily that wetland is for nitrate reduction, but Dr. Crumpton monitors the water quality coming into the wetland and out of the wetland. And that monitoring of what goes into the wetland is really the outlet from the watershed up above. And so what we've done in one of those watersheds in Story County and one in Floyd County is worked with the landowners, the farmers in those watersheds on implementing conservation practices. And what we'd like to see is if we implement those conservation practices, can we see a reduction in nutrients and sediment, but primarily nutrients, coming into the wetland or exiting from those watersheds. And then we would compare those results to a reference watershed or a paired watershed where we're not doing kind of implementation of those conservation practices. So these watersheds are kind of on the order of 500 to 1,000 acres. And in Floyd County, gotten about 70% of the landowners, 70% of the area implemented with cover crops. And we're down at about 40% here in Story County. But also then in some of those implementing, particularly here in Story County, some strip tillage there as well. So the project started in the fall of 2017. So we've had crop year 2018, 2019, and 2020. And then there were about 3 years of monitoring before any implementation of that from a water quality monitoring standpoint. Okay, so we had to move from the field over here, kind of a red flag day, pretty breezy, so that folks can hear us. Mark, maybe you can describe a little bit about what that producer's doing with strip till and cover crops, and then a little more broadly on some of the infield management that's being implemented in this Story County watershed.
Sure. So in that field, the farmer he's been using strip tillage for a number of years. And then this fall, because he's had some experiences with cover crops in other places, this last fall he basically planted cover crops on a 30-inch center, and then he's going to come in the spring and do some strip tillage between those to plant the corn and soybeans that he's planting for there. Overall, this watershed, most of the cover crop acres are new to it, and many of the acres, the strip tillage would be a new practice into it. So this is one of those that we've really seen a pretty big change in the adoption of both strip tillage and cover crops, even though in some cases the producers or farmers have had experience with them in the past.
Yeah. So I think that that field that we were just at and looking at those cover crops, you know, we're a couple days from April 1st. They're pretty small right now, but if I'm not mistaken, he's thinking about planting green in those and then killing it. Maybe some things to think about for producers as they might be thinking about planting green.
Yeah, that's a very good point. And being that we are right around April 1st here, those cover crops are going to take off in the next week to 2 weeks just because of the much warmer temperatures. So they're going to get a lot more growth on them. So that'll change the way they look. Planting green into them, in his situation where he's got them on 30-inch centers, that will make it a little bit easier. The planter is going to go through a strip tillage type operation. So it's going to be, you know, business as usual in large part for him. If you don't have the strip tillage, or if you have more of a solid seeded cover crop, you know, then it's just making sure that that planter is functioning properly. So getting the down pressure on the row units, making sure that the double disc openers are opening up and the seed furrow is able to get pushed shut. That's going to be the key, really, with planting green into any cover crop this spring. So Matt, we're out here, we're enjoying this wonderful day. What is the real benefit of doing a project like this? And then as you talk about that, a little bit about the difference between having fall growth versus no fall growth and what that means even in the spring.
Yeah, so that's a good question. So when we worked on the Iowa Nutrient Reduction Strategy non-point source science assessment, that's a mouthful, but when we worked on that, most of the research work documenting water quality benefits, especially for infield management practices, were on plot scale. So you know, a lot of those on research farms. I wouldn't say, you know, like intensively managed, but managed to try to say, you know, get good biomass growth. And it was on a relatively small scale. So it was certainly recognized when we worked on that there's a need for documenting the performance of these practices at a small watershed scale, or in this case, maybe at the point at which that water, sediment, nutrients are delivered to the stream. And so that's really a value of these types of projects, is that we are capturing the water, leaving a small watershed that's delivered to that stream, so we can quantify, you know, what are the impacts of implementing, you know, that strip till and cover crops in the watershed. And I think that one of the things that, like you mentioned, are really important is how much biomass growth that we get. There's some studies out there really correlating the amount of biomass growth we get, you know, above and below ground, but really above ground is what we routinely measure. Mm-hmm. Most people don't want to measure root biomass. That's no easy task, right? So we do a lot of above ground biomass. And what they found is that, you know, you can relate that above ground biomass to a reduction in nitrate. And so one of the things to think about is, you know, if we have something like oats growing, they only grow in the fall, and so we're going to get some growth, but then we aren't going to get that biomass growth in the spring. And so that's why, you know, some of the research has shown that, you know, on the plot scale, those oats might be about half as effective as something like rye, where it does not winter kill and we get that spring growth. But I really think that, you know, as we move forward with cover crops and thinking about investing, we need to have projects like this that document what may be happening on the watershed scale, but then really looking at how much growth we get as well, because I think that's going to really relate to what we would see for a water quality impact, I think, as well from a soil quality or soil health standpoint also. So before we talk about some of the results here, you know, we're out here in the spring. maybe you can give a little information on kind of some tips for farmers to think about if they're using cover crops and thinking about how they manage that here in this spring of 2021.
Yeah, so the spring management is really going to be dependent on if we're going into corn or if we're going into soybeans. Big differences on how we approach it. Obviously, if we're planting into corn, there's a little bit of a, I'll call it a detrimental effect, whether it's disease pathogens, namely Pythium, or allelopathy, or even nitrogen immobilization occurring, right? So we want to pay attention to that a little bit more. We want to terminate those cover crops 10 to 14 days ahead of planting that corn. So what does that look like? It's going to be corn or cereal rye that's roughly 8 inches tall, right? So something like that. If we're going into soybeans, like we talked about with this farmer, going to plant green into it, that is a practice. Usually we reserve that for farmers that are a little bit more experienced with cover crops. If you don't have the experience, then we look at kind of a 7-day before planting the soybeans that we want to terminate. Again, that's going to look something a little bit taller. That's probably closer to 12 inches of rye growth. The hope is again, we're trying to make it easier, going into, that rye. And we know that if that rye is yellow, there can be some issues with the planter and getting it to flow through the planter all right. So I joke that we either want it green or we want it brown.
Okay. How about if we have any differences if we have wet or dry conditions? So kind of, right now it's relatively dry most places, but we could get some rain and it could get wet.
Yeah, that's a good question. We've been anticipating it all winter, waiting for spring to tell us what's going to happen, right? Northwest Iowa, it's dry, and the forecast doesn't look like we're going to get a lot of rain. That tells me, we probably do want to terminate the cover crop a little bit earlier. We want to try to conserve or reduce water use as much as we can. So terminating a little bit earlier is going to be, a very advantageous type of thing there. You go to the southeastern portion of the state, they've had more rainfall. We're not trying to conserve moisture there, so I think we can let it grow through a little bit longer. That helps, get more rooting action. It actually stabilizes the soil. So even though you are having to terminate it in potentially wetter conditions, the soil will be a little bit stronger, a little bit more able to withstand that extra traffic. So we know that biomass is a very important thing. It has great ties into soil health. How does this come back into play as we think about the water quality effects of it?
Yeah, I think it's really important that biomass, we need that biomass to take up that residual N that's in the profile, or the nitrate that could be susceptible to loss. And certainly as we look at the nutrient reduction strategy, we saw pretty good estimates from our plot scale work. And we now have 3 years of water quality data at these sites, and we had 3 years pre-implementation of cover crops. And to date, we see about similar kind of trends in nitrate in the watersheds where we have cover crops compared to those that we don't. So, if the watershed was higher before implementation of cover crops, it's still higher now. So we would expect, what we'd hope is we'd see it diverging, that those watersheds with cover crops, we might see lower nitrate. To date, in these 3 years, we haven't. I think one of the reasons is we maybe haven't gotten as much cover crop growth as we might in some years. So 2021 will be a good year in some of these areas because I think we've had a little bit warmer March to get those cover crops growing a little bit compared to what we've had in some years. We may be also seeing some time lag, with kind of the water movement, although we would expect in these tile drained watersheds to perhaps see it in 3 years. So I think that's why this scale of monitoring is so critical, because we really need to be able to see, do we see the benefit that we would expect from some of our plot scale research.
As a follow-up to that, Matt, how many years, you said we have 3 years pre and now we're into 3. How many more years do you think we need to know to kind of get at, is it a biomass thing or is it, just a lag period?
Yeah, that's a great question. And, I don't know the exact answer to that, but I think we'd at least try to collect a couple more years of data. So we have 5 good years of data. But even after that, I think it would, maybe we can get up to 10 years of data on this. And also see, in years, there may be some years we get a lot more growth, and do we start to see any impact in those years? It might give us a little information about how much growth we need to see an impact at this scale.
All right. So again, if you have any questions, feel free to type those into the chat. I know Matt's going to go into a little bit more detail on some of the water quality data, and then we'll open it up for discussion.
Well, first off, I want to say, don't blame Mark and I. We thought the weather was going to get warmer, and it didn't get any warmer. And it's gotten a little less windy, but not much less windy than that day we were out there.
It was warm for the next week.
Okay, yes. Yeah.
And then it got cold.
So actually, can I ask a question of Mark? Just kind of thinking about that and looking at the forecast that we have for colder weather. And I saw something on Twitter this morning about, are there things people should consider if they have cover crops out there and thinking about trying to terminate those with herbicide and maybe these cold temperatures?
Yeah, Matt. So that's a very timely question, because that's been in my inbox and in conversations the last several days, really. So we know when our air temperatures at night get below 40 degrees, glyphosate's not actively going to terminate the cover crop well. And then we want to do those applications when we have air temperatures during the day, mid 50s or greater. And so the last week, we've been challenged on some of those points, right? And so the question that we're getting is, how do we get the most effectiveness out of that termination? And one of them is waiting to get the right temperatures. But then the other part of it is, let's not use any UAN at all. Let's make sure we use either AMS or other adjuvants, at appropriate rates to help with the glyphosate activity, right? And then the other question of it is, do we do it now and hope we get good effectiveness, or do we wait, until maybe we get a little bit of a warm up in the coming weeks? And that's a good question. And I don't know that I actually have a great answer for that, because if we delay termination on the cover crop now because of the cool weather, does that mean we're either going to be planting corn green into that cover crop, or are we now delaying corn planting? And that's a pretty big trade-off that we have to consider at this point.
All right. Thanks, Mark. And I guess, I'll touch on maybe a couple other things relative to water quality, and we'll maybe share my screen here, and folks could go back and see the, excuse me here. There we go, the Learning Farms blog. Could go back and watch a webinar we did a couple weeks ago talking about the CLL and some of the water quality data. But one of the things that I think is important and is that cover crop growth. We talked about that on the video, and getting that growth, getting that biomass of cover crop. Some work has shown that the nitrate reductions that we get from cover crop can be correlated to that biomass. And we got some pictures from a producer that had done some different cover crop seeding times, and Liz put these on the Iowa Learning Farms blog today. And I think we can see some of the differences in growth that they've seen this spring with that. From this upper left of an aerial seeding on August 16th at 1 bushel per acre. So I think these are pictures taken this spring. And then, on the right, we see one where they drilled in 2 bushel per acre, and that was on October 6th. Then down below, we have drilled into corn stalks on November 1st, or broadcast with dry fertilizer on November 20th. And I think we can see in both of those lower pictures, as we get to that later planting date, there's maybe less growing degree days between then and now. And so we don't get as much biomass growth of that system. So, sometimes we talk about, is it a management issue why we don't get growth? Is it a weather issue? Well, we kind of have to have the management that gives us the best chance of growth. And there may be some years, a lot of years, where those later seedings, we don't get as much growth as we would like, and maybe as much growth to see the water quality benefits that we want. And so I'll just show briefly here that at these CLL sites, here's one in Story County. So you can see, actually the Story County is a good one to show, because we were where Mark and I were standing out of the wind. The one little shed that we could stand out of the wind was about right there, right at the base of that watershed. And so about half of that watershed area is in the past has been in cover crops. And so, as we talked about in the film or in the video, we've been monitoring these for a number of years now for water quality coming in and out of the wetland. I'm going to talk about what's coming into the wetland or out of the watershed area where we have cover crops. And so this was an example of, kind of late 3 years ago, late growth or late April growth. And you can see again, not a tremendous amount of growth in that, especially that Floyd County site. Oh, come on, why won't it move forward? There we go. Okay, so Dr. Crumpton again does the monitoring on the inflow to the wetland or the outflow from the watershed. So quickly here, I will show you here's the kind of the upshot on the nitrate yield or nitrate concentration. The control watershed, again, there's been no active work with producers there on implementing cover crops. The treatment watersheds, we've had active work to implement cover crops in those. You can see the black dashed line there is distinguishing between pre-implementation and post-implementation. And what we've seen is that the trends between the control and the treatment have really followed the same post-implementation as pre-implementation. And what we thought was that we might see some diverging, and that the treatment would be further away or lower, or if they started lower, it would get more, even greater difference between the two. But we've not seen that to date. And so, a lot of questions about that. And I think one of them is there are two things that may come about. One is there may be some lag time here, even though these are relatively, I wouldn't say intensively drained, artificially subsurface drained watersheds. There still might be some lag time for the water that's leached from the plant root zone that might be a little lower in nitrate to make its way to the drain and ultimately out. I guess I would have thought we might see some differences within 3 years if we were dramatically reducing that nitrate concentration leaving the plant root zone. The other is that maybe we've not had enough growth to overcome the variability that we see. So if we look back at the nutrient reduction strategy, it said an average of a 31% reduction, but that range was from about 5% reduction to 60%, or from 0 to 60%. And so there's a pretty wide range on that. So I think it just illustrates a few things: the need that we need to work to get as much growth as possible, and that we need to look at these issues over the long term. I would also say, kind of the last point is, it also illustrates that we need to kind of have multiple practices, because some of the edge of field practices will, these are good example watersheds. There's wetlands at the exit of those watersheds. Even though in these years we're not seeing nitrate reduction with cover crops, those wetlands are removing nitrate every year. So I think it really illustrates the need for thinking about this comprehensively, both in-field and edge of field practices. So I've rattled on long enough. Let's get to some actual questions from participants. And sorry, my phone was ringing. My gosh, I'm a mess today. Okay, stop share.
All right, so some questions have come in. Someone's curious, what is the time or times of the year the water is being measured in the growing season?
Yeah, good question. We're measuring, in this study, we are measuring year round. And so the way Dr. Crumpton has that is during the non-freezing times of the year, they have those auto samplers out there, and they are collecting a water sample. And this is combined surface and subsurface flow where they're monitoring. And they are collecting a water sample every 6 hours. And then like they'll put 4 of those every 6 hour samples into a bottle that's acidified to preserve it. And so that's a daily composite sample. During some of the non-freeze or during some of the freezing periods of the year, they would go out there on a weekly basis and take some grab samples. So it's a pretty robust way of water sampling. And actually, Dr. Crumpton published a paper that came out in JEQ about a year ago on the performance of these types of wetland systems, for which I think some of this data on the wetland performance from some of these watersheds was in there. So I'd be happy to get that to somebody if they wanted a little more detail on how they do that monitoring.
So also curious if there's any soil health parameters being tracked in these sites in addition to water quality.
Okay, yeah, this is the same person that asked it last time because that was the same question. We did collect some soil health parameters when we started one summer. Emily Waring and Maddie Tusha and maybe Sam Phillips, Mark Jacobs, is kind of a whole crew. In fact, we got a video of them out. They made a summer video out there. So they did about in 2017, 2018, got some preliminary samples. You know, hope there would be the hope that at some point in time we can go back and collect some of those. You know, if it's any indication from, you know, some of our smaller plot studies where we've monitored that, you know, I don't think 3 years is enough to see measurable improvements in some of those metrics. Maybe Mark has something to add on that too.
No, Matt, you're right. Getting differences in the soil health metrics takes multiple years. And so in the short time that we've been with this project, I don't think we would see any large changes. You know, I think it's going to take, you know, 2, 3, 5 more years before we start to see those.
Matt, this one goes back to you. They're curious, or he just shared the Crumpton paper in the chat for those that are interested in looking into that. But someone's curious, were nutrient applications identical for control and treatment watersheds? If so, is it likely that in real world circumstances, you might reduce N application on fields with cover crops?
Okay, so that's, yeah, very good question. No, they were not the same. And that, no, that's right. And so that's why, you know, I think that's one reason why we see some differences. First off, you'd have some differences in site-to-site variability in soils that would influence, say, why we saw a difference between the control and the treatment watershed even before implementation of the cover crop. So I think likely some of that difference may also be due to differences in rate. So as we talked about on the webinar, we're going to do a little more on capturing nutrient application rates in the control watersheds, but you know, we would not expect, or we've not done anything to yeah, they were not the same. Okay, and because we just went into 2 watersheds, but we had, you know, having 3 years of pre-implementation data is pretty darn robust in this. On the other, you know, I think that the jury in some ways is still out about whether somebody could reduce their application rate when using cover crops. And so maybe that one might be, you know, Mark, from a cropping system standpoint there.
So in some of the initial work that John Sawyer has done and some of his nitrogen colleagues around the Midwest, they're not ready to say that we can reduce our nitrogen rate following cover crops. But at the same point, they pretty adamantly can agree that we do not need to increase nitrogen following a cover crop. So the nitrogen demand from the corn crop is going to remain the same. part of it is just going to depend on what is the cycling from the cover crop uptake and as it recycles back and becomes available again. And so I think we do need to have a little bit more work around that. I think part of the challenge with that is that we tend to, at least in Iowa, we have a lot of rainfall most years, or enough rainfall that we can start to get nitrogen movement within the soil profile. And that does complicate, how we look at this and our ability to look at it more robustly.
And I shared in the chat there a link to the Whole Farm Conservation Best Practices Manual that goes into a little bit more detail in terms of nitrogen application recommendations for those that are getting started with cover crops. Yeah, Matt's got a copy of it right there on his desk. So there's some management directions in there regarding nitrogen application. And to add on to Matt's comments, I worked with the producers in both the Floyd and Story County treatment watersheds to go through the conservation planning process with the NRCS, which did have us look at and examine their nutrient applications and then make sure that those are within the recommendations of like MRTN and things like that. So most of them were already in that, but it was just a good inventory of what was being done in that watershed. And so those producers definitely give us a lot of information, and we're still working to collect from those that are willing to in the control watershed to some level of that information. So I'll toss this out to both of you, but someone's curious what research might be occurring in Iowa to capture nitrate reaching shallow aquifers as opposed to nitrate being intercepted by tile drains. So maybe that's more of a Matt question.
Yeah, that's a great question. So there's not as much work because it's not quite as easy to monitor. The Iowa Geological Survey, Keith Schilling has probably done as much as anyone kind of monitoring some shallow groundwater wells in various places. So I think that's a good resource. One of the things in these tile drain landscapes, they're like big lysimeters in a way, that the water that falls and leaches from the plant root zone is then intercepted by a tile line or moves through lateral subsurface flow and then intercepted by a tile line. So I think in some ways, they're indicative of what might be leaching below the plant root zone in a non-tiled watershed, but we don't have as much, we've not done as much information collection or research on that. There would be more of that that might be relevant from Nebraska as well, because they wouldn't have tile drainage in there. They are looking some at nitrate movement below the plant root zone there. So.
Yeah, and I had someone ask about it.
I should, just a second. I'm sorry, Liz. One of the things that we will use, it's not there. It's fraught with some challenges, but and Liz knows this well, as she helped put them in, collect a lot of samples. Is that we'll use suction lysimeters to try to get a measure of the pore water, or get a sample of the pore water in the unsaturated zone, kind of within the root zone of the cropping system. And so we did, the broader we, because I was not, the Iowa Learning Farms did that on 5 sites throughout Iowa, many off the Des Moines lobe. So, not in as much of the heavily tile drained areas. And so, we saw, nitrate movement through the plant root zone in those areas, even where we don't have artificial tile drainage. So there has been some of that to collect that pore water and unsaturated zone water that would ultimately have moved to shallow groundwater.
And I'm pulling up that publication now to share it in the
Great.
The
Cool.
chat for everyone.
Yeah, and that one, Emily Waring is working on getting that all written up for a journal publication. So that one's interesting because it looked at cover crop mixture. So one of the questions at that time was, was it before soybeans? It was either rye or rye, rapeseed, and
Radish.
radish. And so what that work found is that most of the growth, this was all hand seeded or overseeded kind of a week or so before Labor Day. And what was found there was most of the growth, even in those mixtures, ended up being from that grass species rather than the rapeseed or radish, or then before corn, it was oats, hairy vetch, and radish.
Yeah.
I got them. Yes, it's only taken me 5 years, but I remembered them. Okay.
Yeah, and so someone asked if there was a way to get some of the slides that you were showing with the reduction, and we actually have some preliminary data analysis on our website from this project, both Floyd and Story County, so you can check that out. We'll be providing another update following this summer, so you can come back and look for that late summer, early fall to include this past crop season in that data analysis as well.
And we will hope that we get some rainfall so we have a little more water flow, because
Yeah. So you mentioned the need for edge of field practices as well. This person is curious, what in-field practices would you stack with edge of field practices? Like, what would be your ideal combination of practices? I'll throw it to both of you.
Mark, you take it first. I've been answering first on too many.
I sometimes get in trouble. No, so in-field practices, obviously, I think we can look at honing or fine-tuning our nutrient management, right? So nitrogen, phosphorus. When we look at the nutrient reduction strategy, those are going to only give us small incremental changes, right? I think if we want to see some of the bigger changes, I think we're going to have to look at cover crops and no tillage / strip tillage. I think those are, for the most part, in a corn soybean centric rotation, those are going to be the three that we really would want to look at. I think if we really want to see some big changes, it will take a little bit more work, but I think we need to look at some extended rotations. So can we grow some small grains and interseed in or frost seed in some red clover or something like that? So now we're looking at a 3-year rotation, or even a 4 or 5 year rotation with alfalfa, something like that. Again, I fully recognize that the market potential for any of the small grains or even alfalfa is going to very quickly reach a saturation point, right? We're not going to be able to transition 24 million acres into a 3 to 5 year rotation. But I do think that in very sensitive areas, an extended rotation would be a very, very good option.
So I would agree with Mark completely. And I think that, we can kind of think of, we go back to some of us, Mark and Jackie and Liz and others, we've been working with the learning farms for a long time, and think of a conservation systems approach and trying to protect that land all the way from the top of the watershed to the bottom. And so things that we can do in field to reduce that movement of water or soil erosion. A lot of times I know I get accused of only thinking about nitrate, and I need to be careful, but the no-till and cover crops. So even if cover crops maybe don't have as much of a nitrate benefit as we hope in some of these years, there's still something protective on the soil surface to protect some of the soil erosion. Go watch a couple of the little videos that the short videos that the student clubs had yesterday on soil health, and how that can help erosion. So I think that, protecting that soil surface can help us with reducing soil erosion as well, and phosphorus loss through that mechanism. I think the only additional one I would add is to think about, and this kind of, again, plugging some webinars, but Stephen Hall has talked about some of the wet areas of the field being disproportionate, or seeing higher losses of nutrients because they're so wet. So there may be lower crop production, higher leaching losses, maybe higher emission losses. And so can we kind of redefine the field edge? Mark and the Learning Farms project on redefining the field edge. Can we think about some of those areas that maybe we're not getting good crop production from? They might not be profitable. Can we look at putting those into some type of perennial vegetation that that helps us reduce that nutrient loading down to those edge of field practices as well. So just one more thing maybe to add to the mix.
Hey, Matt, you brought up something or touched on something as far as the infield practices are helping keep that soil in place. And that made me think about one of the big benefits of like no tillage, strip tillage, cover crops is really the soil health benefits that we get from those. Those are, on all those production acres, that's going to be improving, especially over time. It's going to be improving our soil health. Not that edge of field practices are bad, but that's a detriment of edge of field practices is that, they're only improving soil health on their footprint, more or less, right? But they give us the big benefits in the nutrient reduction. So there's sometimes some balancing act that has to go on between the two.
And every time I hear soil health and then we think about soil erosion, I'm reminded of our colleague, Dr. Cruz, that says, the first step to healthy soil is reducing soil loss and getting that to kind of a tolerable rate, or not below a rate that's, consistent with what soil regeneration is. And so, even if we don't see maybe some of the, metrics of, aggregate, water stable aggregates or some of the other factors, short term, we may still be keeping that soil from being lost, which is a benefit.
So to kind of build on maybe even the aquifer question, but can you assume that in untiled soils, rooting would be shallower and would not take up as much nitrate than under larger root masses in tiled soils?
I would say it really, this is maybe Mark's a cropping system person, but one of the things I would say in a lot of untiled soils, you would not have high water table conditions. So if we think about some of the loess soils, we're not going to have high water table conditions that would prevent some of the root growth. So if you're thinking about untiled soils where we have naturally well-drained soils, I think you will get good rooting depth.
Yeah, Matt, I would agree with you. I think one of the things that tiling would do is it would help you get more rapid root growth in the top 2 feet,
Mm-hmm.
or above that tile zone, right? Because what you're doing is you're artificially lowering the water table, right? Obviously, the roots aren't going to grow into that water table, and so that's where they're going to maximize, or as far as maximum depth is going to be, where you have water table, it's going to be limited to that depth. And so I think you'll get a little bit quicker, potentially quicker growth of the roots down, at least into that zone.
So one of the things we have to remember when we have tile, for us to get water flow to the tile, that the kind of the saturated water level has to be up at or above the tile depth. I frequently, or not frequently, I remember vividly getting a question from somebody in Nebraska. They had read something that tile drainage improves crop yield. And I said, so where's like the natural water table level or the high water table conditions? And they say, about 10 foot below the ground. And so that's at a depth that if you put tile in, you're probably not going to get much flow out of it because most of that's going to move vertically down to the saturated zone. So what happens in our tile systems is that water moves primarily vertically through the unsaturated zone, and then it'll move laterally in the saturated zone to that tile line. But if the tile line is above where that saturated zone starts, that you can't, it's not going to force water uphill to the tile.
And someone is curious on how the derecho affected Story County results. So I can speak to that actually, because only the one field we went to for filming did get seeded this fall because of the derecho. So the majority of Story County actually did not have cover crops seeded this fall. So that'll be something that we'll take into consideration and looking at the data, because that farmer did have, a good portion of their crops impacted. And Mark lives not too far from there and saw the damage himself. To know that it was a challenge this year for sure for many producers along that pathway.
Yeah, so actually it'll be kind of could be an interesting observation that we've had 3 years of cover crops in the Story County treatment watershed, but because of these factors, it did not get seeded in the fall of 2020. So, maybe we'll see those lines coming closer together, which might indicate that those cover crops were doing something the last 3 years.
So I just want to open it up. I haven't really given anybody a chance. If anyone wanted to ask a question themselves, they're invited to unmute and ask those questions or keep them coming via the chat box.
I had a question, and this might be a question for Mark as well. Timing, this individual indicates timing is key with cover crops, so, sowing and termination. Personally, they know the farmers I know are using cover crops, farm, a lot of acres. The larger producers, 3,500 to 6,000 acres per year would like the benefits of cover crops. But, are they farming too many acres to be able to do those things timely? That's it's a great question. I would say, it kind of depends. Yeah, of course, right? I'm from the university, so I say it depends, but it may depend on what the level of labor that you have. If it fits in with the labor that you have, maybe it works. If you're willing to, custom have it done, then that's another factor. But I do think that, those would really, to me, those would be real observations or real constraints for some. Mark,
I don't know.
Yeah, go ahead.
Brian wanted to ask a question there. I'll let him get in, and then if Mark wants to circle back to that.
That was my question I posed. It's kind of funny. About 10 years ago, getting into cover crops, I was just working with my person. Hey, what are we doing with cover crops? Said, well, we've tried it for 2 years. We did the aerial seeding with the dense drilling of the corn, no-till. It catches in the canopy, right? It's just up there. And so, but and they're doing about 6,000 acres. Now, another neighbor of mine, I talked to him, he eats and breathes cover crops because he's doing less acreage. His model means that he has more opportunity farming less. Now, so as a rule, I don't know if there is a rule, okay? If there's a diseconomy of scale for someone that's going from 2,000 to 4,000 to 6,000, realizing you've got to send equipment down the road and back, you've got to plant, you've got to fertilize, that, it seems like we always say cover crops is the way to go. And I kind of got pulled up, had a reality check in my local county on that from the people who are farming. Yeah. And so, I kind of pulled back on that, but I'm sure there's a lot of things that shape attitudes, but that diseconomy of scale versus the economy where you're getting ahead versus falling behind with the more acreage. And that's, I could keep going on now, but that was my big one. Thanks.
Thanks.
Brian, that's a great observation. And so my initial gut reaction is saying, well, cover crops can actually save you labor if you've bought into moving into a no-till situation with them, right? You're saving labor from tillage in the fall. You're saving labor from, any spring seedbed prep, right? So from that perspective, I think there could be some labor savings, and it could work for some larger farmers. I think that maybe what happens with the larger farmers, and again, if there's any out here that can shed some light on this, I'm all ears. Is it more of an intimidation factor, of I've got this many acres to do and I just can't get it done. It's a high learning curve with cover crops, right? So that's when I step back and I say, well, maybe we needed to start with 40 acres, get comfortable with how it's going to work, and then slowly increase the acres to figure out how that scale is going to work. I don't know. I don't farm that many acres. I have 4 on my acreage. So
yeah,
you're fine.
Thank you, Mark. Just to follow up on that, the timing, the termination is key, right? To get the benefit, and you need to have the field conditions just right. And so that's to get the benefits of a cover crop, you share the same type of risk perhaps that you would have with your row crop.
Yeah.
Right. There's a risk involved, but as we know, the nitrogen costs going up, it makes things more attractive. So, hey, thank you so much. I always enjoy these seminars. I'll let someone else have a turn. Thanks.
All right. Anyone else have any questions? Go ahead, put those in the chat. And while you're doing so, or feel free to unmute, I'm going to share my screen one more time. For those of you that joined us today to get CCA credits, please be sure to get that information to me. My email is there, and I'll put this in the chat as well. But get that to me by 5 p.m. today, and I'll get that submitted so you get your CCA credits for attending today. And it does look like maybe Scott, do you have a question?
Yeah, I was going to ask Matt or Mark, have you seen anybody up there in the area try to start with the yield mapping and that kind of data collection to kind of find somewhere where they can start their cover crops without really impacting their bottom line to begin with, and then let them kind of gradually grow through that process?
You know, I've heard some discussion about that, but I don't know that I've been interacting with anyone that has really worked on that closely or done a lot with it. I know that normally we would say, you know, starting out with new practices, some of the most productive acres can sometimes make it easier because those are inherently good producing areas. And so as you want to learn how to do practices, they're lower risk, right? But again, I don't know that I've seen anyone trying to place cover crops based on yield productivity zones.
No, but we have been working with folks to put perennial vegetation in places.
Those low productivity zones.
Yes.
Yep.
Yes.
I really think, and I was just on defense, you know, I really think that utilizing, you know, so many producers have, you know, multiple years, maybe decade or more of yield data, and really starting to think about, you know, are there areas of my field that are, you know, that over a 10-year period have lost me some, have not been as profitable as I would like, or not been profitable at all, and can we start to rethink what we do in those areas?
Yeah, that's probably where productivity mapping is really going to be extremely beneficial, because you can very quickly pick out areas of fields, you know, and so my dad and my grandpa and my brother who's farming now can very easily tell me which areas of the field they are. They can't quantify it, but they can tell me which areas of the field, right? But now with productivity mapping, we can transfer that into profitability mapping, and you look at that from 1 year to the next over a 10-year period, and you very quickly figure out, wait a second, we shouldn't be farming some of these acres.
There's one more question that came in, and I don't know if I have an answer to this one either, but do I go to an Iowa State football game this October or stay home and plant cover crops all day?
Oh, now that is a good one.
What I'm
Okay,
going to say is that
I'm not.
hope it's raining at home, so you can't be out there
There you
anyway.
go. There you
And
go.
it's beautiful in Ames.
That
And
is,
enjoy the football game.
yes.
I was going to be selfish. I was going to say, turn on the radio and listen to it while you plant.
There you go. Okay, that's a good one too. That's a good way to end.
So thank you.
Okay, now, yeah, yes, I'll leave it. I might have a different answer if it was November 15th rather than October 15th.
Exactly.
So thank you all so much for tuning in today. Again, this is being recorded. You'll get a copy of that in an email this afternoon with the evaluation. Feel free to share that recording out as you see fit. And we look forward to seeing you on a few more virtual field days this summer as we take a closer look at some EduField practices in the hopes of returning to in-person field days this fall. So thank you all so much for tuning in today. Liz,
I just want to make one comment very quickly because I did see one of the attendees, and I'm not going to put him on the spot in any way, but I really want to acknowledge former Secretary of Ag Bill Northey, who I see his name on there. Secretary Northey was very instrumental in getting this CLL project started. And I think, came out and met with the farmers to really talk about the importance. And so, we think this is, pretty important for us to continue in the future. We feel fortunate that we've been able to collect this many years of data, and think it's important for us to continue to do it, because I think it helps us understand that what we can expect and what we need to think about relative to things like cover crops.
Appreciate it, Matt. Thank you. And certainly very pleased with all the great work that's going on, including everybody on this call, and the growth in cover crops and the work that's going on. We're really proud of Iowans and Iowa State and the connection and learning farms, and just great stuff.
Thanks.
It's a great looking field you got there.
Yeah, that's right. Yeah. All right.